Hi, this is papaisniu and welcome back to Human Resource Machine. So this is it, level year 41. Okay, the last one, I recall this is really hard to optimize. Okay, we see what we can do. All right. Well, without further ado, okay, let's check it out. Sorting floor, year 41. Okay, check out. Sure. Okay, hi. Sure, I don't think it's his supervising skill. Okay, your skill are pretty good to whatever it is you do there. There's like no visibility to this box. Sure. So are you ready? Okay. Come on. Tell me more. How do you sort? Don't ask me. Sometimes I eat the bread before I make my sandwich. Alright. Sometimes I put my shoe on before my socks. And I think I'm getting younger. What? I don't think I was ever a kid. Were you? This is a very weird person in general. Yeah, I have no comment. Okay, some codes are here. Okay, so for each zero terminated string in the inbox, sort the content of the string. Smallest first, biggest last, and put the result in the outbox. Okay, repeat for each string. Okay, so what do we have here? Let's try. Okay, take 0, sure, copy to here. Okay, inbox, put, bump up. Okay, continue to put. I see. Okay, so what it does is it just put everything there. Okay, it just put everything there. When there's a 0, you'll still write it in and then jump. Alright, sure. The length is 3 in this case. Okay, do we want to keep this code? Okay, this is about sorting, right? Sorting. The most expensive step is to perform the swap. Alright, I'm going to do swap. Then that would require me to exchange two things. Okay, to exchange is a little bit expensive. Okay, I need to write this somewhere. I need to read it, write it somewhere, then read it, write it here, then read it, write it there. Okay, somewhere else. That's a bit painful. Okay, what I meant is I need a temp. Okay, so seems like this code make use of this one to count the length. Alright, I'm going to store length, length. Okay, the length. Alright, so this is the length. We can store a temp value. Alright, so when we want to swap, we have to copy. Let's say I want to swap cell 1 with cell 2. I have to copy this one, put here. Copy cell 2, put there. Copy temp, put here. Okay, the swapping is painful. I guess the most painful thing about sorting. Okay, so let's try to see whether we can minimize sorting. Alright, let's call this 0. Not sure whether we need the value 0, but let's just do it first. Okay, copy 0 to length. Take from inbox. Alright, so everything's populated. Sure. Alright, if it's 0, finally we can start the whole thing. Alright, what should we do? We should check. Should I put the largest one in front or the smallest one in front? Okay, when I return, how should I check? If I go up, okay, I return from this one. Okay, I need to check whether I reach length. So I need to perform index subtract length. Correct? I need to store index. This is where I am. Index subtract length. Is it 0? No. Index subtract length. Is it 0 or negative or what's not? Okay. If I count down seems to be more effective, right? So I start with a length. I just subtract it until it reaches 0. Okay, countdown is more effective. So I guess I'm going to store largest first, smallest behind. Largest first. Okay, largest first. So what I'm going to do is to, I guess, find out which one is the largest. Correct? Find out which one is the largest. If it is the largest, I am going to store it as temp. The largest one, then I shouldn't call it temp. Let's see, let's try to call it max. Okay, max. So the largest among all of this, okay, will be stored here, and I'm going to put it to here. Alright, so I need two indexes actually. I need an index I and an index K. Hopefully I won't be confused with this. Okay, one of them I will iterate through. K is like the lower bound, so once we fix this as the max, K will become 1. So this is the lower bound. A little bit involved. Alright, here goes nothing. Let's try to see whether this algo work in to get either the size or the speed challenge. Okay, size 34. Oh, wow, speed. Whoa, wow! Just now was the year before was so much lesser compared to this madness. Okay, let's figure out. Let's see. Copy from. What should I do now? I need a running index. Correct. So copy from 0. Copy to K. Copy to I. Alright, so all of them are now 0. I will run through all the way to length to help me check. Maybe I should run downwards also. Should I also run downwards? That is an interesting idea, right? Okay, copy from length. Copy to K, copy to I. Then I shall run downwards. Okay, and find the smallest number and chop it behind. Alright. Length is 3. Copy from length, copy to K. Bump K down first. Copy to I. So length is 3. Means like this case, this 3 thing is populated. Cell 3 is populated with 0. So I should bump K down to form 2. I is 2. So I start looking at this term. Okay, I start looking at this term. Should I in general just bump down the length? Okay, details. Let's leave the details to later. Okay, create a solution first. Alright. What do I need to do? I need to... Oh, let's see. 0. I'm actually here. Okay, this is 45. This is actually 45. I actually want to just copy it into max first. I would actually want to just copy into the max first. Copy from this one. Copy to no longer max, mean. Okay, right nicer, mean. Okay, minimum. Copy from this one, copy to minimum. Then I'm ready to bump it down again. Alright, so maybe I should actually have bump length directly. Just bump length. Copy from length, bump length. Okay, copy to K. So K is 2 for this case. Alright, 2. And then I copy from this cell, I directly put to minimum and bump K down again. So now it is 1. I should check whether it is 0, whether it's negative. Correct, I should check whether it's negative. If it's not negative, then good, we still have time to go. Bump K down. Bump K down. Am I doing the right thing? I'm not doing the right thing. I need to actually work with I instead. Okay. K was 2, it was copied. K become 1. When it become 1, I want to copy to I. I is the one that I want to bump. Okay. If it is negative, what should I do? Copy to I. If it's negative, no, then I don't care. Okay, if it's non-negative, then I should take a look at the cell. Okay, take a look at the cell. I should check whether it should replace minimum. So this thing had to be smaller. Copy from cell I. Copy from cell I. Okay, check whether it is actually lesser than the minimum. Okay, so subtract is negative. If it's lesser than the minimum, I should update the minimum. Correct? Otherwise, I should just bump I and continue to check whether it's negative. Alright. Looks good. Looks good. Okay, looks good. Check whether it is negative. Okay, there's potential to save a step here, I think. Correct. I could bump K. I could bump K later. I could bump K later. Details. Let's go into that later. Okay. What happened when this happened? When this happened, I will have to. Let's see. Just take it to the bottom first. Copy from I, subtract minimum. If this is negative, I need to replace. Replace this. Copy to minimum. Okay, replace minimum. Then now I have a new minimum. Alright, now I have a new minimum. Then what do I want to do? I want to copy from what should I do? I should go back to here. Alright, so this part of code should be able to amortize. Yeah. Oh well, we'll amortize it again. Okay, we'll amortize it later. Let's see whether we can make it within 34 for size first. Okay. If it's negative, copy from that, copy to minimum. So we identify a new minimum. Alright, we identify a new minimum. And then we continue to bump. Then we check whether it's negative. When it becomes negative, what will happen? When it becomes negative, then it is time to update the minimum. Update the minimum. I could have. How could I update the minimum? Oh, I have to swap. I have to swap this time. Alright, so this is the painful step. I have to swap. There have to be a temp, I guess. Update the minimum. Actually, the minimum could have stored address, right? The minimum could have stored address. It will make life easier that way. The minimum could have stored address. Would that be better? Copy from I, copy the minimum. Yeah, it would be better. It would be better. Copy from actual I. This is the minimum address. I minimum. Okay, the minimum in index. Alright. So here also copy to K. I don't want what K point to. I want the value of K. Nice. Alright. Okay, so copy from length bum K. Wow. Okay, length is 3. Length is 3. The length has bumped down to 2. Okay, K is 2. K is 2 is good. Then we don't want to bump down K. Then we will bump down I. Okay, I is 1. We want I to be 1. Alright, that's good. Then in this loop, we could cover this and remove this. Alright, so I is 1. Alright, if it's negative, we are done. Alright, if it's not, copy from here, subtract what I points to. Okay, if it's negative, I have something smaller, so this is done. Alright, nice, this is good. Alright, this is good. Then what should I do? Copy from I, copy to I minimum. Copy from I, copy to I minimum. Okay, okay. Okay, let's swap this too. It shouldn't have a problem with that. Then if it's negative, go here, copy from I. Alright, we don't need the jump. We don't need the jump. Effectively, there is the jump already. Okay, so copy from I, copy to I minimum. The jump. Okay, then bump. Nice. Okay, if it's negative, what happened? If it's negative, we are done. We want to copy from, there should be a temp. There should be a temp. I think we can't avoid this. Okay. Copy from what K points to. Okay, for this case is 2, right? Copy from what K points to. And then I copy to temp. Then copy from what the minimum value is, copy to K, what K points to. Alright, lastly copy from temp, copy to the I minimum. Alright, so this part is done. After this part is done, we are ready to decrement K. Decrement K. After we decrement K, right, we have to copy to I. I have to copy to I. After we decrement K, we have to copy to I. Looks okay so far. Looks okay so far. Okay. When we decrement K, and then we reaches 0, nothing to swap. So jump if it's 0. K is 1, we might still want to swap. Yeah. Okay, so if it's 0, we will want to output everything. Right, if it's 0, we'll want to output everything. There's some amortization here though. There's some amortization here. If it's negative, jump to here. So let's create the amortization. Okay, if it's negative, jump to here. Right. What should we do? If it's negative, copy from K, copy to 10, copy from I, copy to K, copy from 10, copy to I. Okay. With all this done, we are ready to bump K, check whether it's 0. Alright, and this jump will not trigger. Nice. It will be this if negative. This will happen. Okay. Jump if 0. What happens if K reaches 0? If K reaches 0, we are ready to output everything. So we should go to length, which is currently 2, right? Length is 2 because we decrement it before. Okay, length is 2, and then we shall copy from length output. Okay, so go all the way in front. Length want to reset to 0. Okay, looks good. Alright, here amortize. Okay, what do you want to do? Well, copy from what the length point to, outbox it, then bump the length down. So when length is negative, then we are ready to stop. Length negative, we are ready to stop and reset the length. Alright, otherwise, jump. Otherwise, we shall repeat. Looks okay. Let's see where things fail. Okay, first part, just write everything there. Try to perform the swaps. It looks like it's swapping well. Looks like it is. Right, read everything first. Okay, looks like it performed correctly. Let's figure out the size is 34, right? How much operation did I use? I couldn't really see. I think it goes down. Alright, come on. I used 34. Nice. Whoa. Okay. I think it was 34, right? So I might have hit the size challenge. That is good news. Alright, that is good news. We'll take a look. Wow, this sort is madness. Wow, madness. So 24 plus minutes, assuming this thing run to completion, I'll have my size challenge. Okay. Wow, this madness, I think it's really slow. Yeah, it's not going to hit the speed challenge. Hopefully not by too wide, actually. What happened? Tile with address -1 does not exist. Singleton, single element. I wasted all the time, man. Single element. Okay, single element. Let's figure out. If I have a single element, copy to length. Where am I? Here. If it's 0, jump. Alright, sure. Copy from length. Bump length. The length was take the inbox, copy to length 1. So my length is 1. So copy from length. Copy from length bump length. Why do I need that? That will save one operation, I think. That'll save one operation, right? Nice. I like. That'll save one operation. Okay. Bump length. They become 0. Copy to K. K is now 0. K is now 0. The check for whether K is 0 is here. The check is there. Bump length. What will happen if it's not 0? You just continue. You will just continue. Alright. On the inbox. If it's 0, then copy from length. How should I do this? Copy to K. Copy to K. If K is 0, we are ready, right? Copy to K. If K is 0, we are ready to finish the whole thing. So if K is 0, I can actually jump here. Bump length. If after I bump is 0, this is singleton. Copy and out. Alright. Whoa! I think this is correct. It would be nice if they come out with the singleton string first. Okay. But it doesn't. Alright, it's going to push all the way to the end to show me that string. Wow. It is really not very efficient for a long string. Like the one that's coming up next. Wow. Crazy. If only there's an easy way to do it. I think I'm heading in the right direction though. You want to do too many swaps. Correct? So this method, for example, this length 9, okay, this length 10, I'll at most do 10 swaps, which is very big. I would potentially do more swaps, actually. Correct? I'll potentially do more swaps than 10 using other method. It should be correct though. Swapping is so painful. Swapping is like what? 6 steps to do swapping. That's so painful. should be correct. Okay, anyway, let's this series figure itself out. Alright, so the series is correct. Okay, written correctly. And then now the moment come whether we return the 72. Nice. Yes, this is done. This is done. Do I have size challenge? Yes, correct. 34 was right. Yes. Okay, speed challenge, short distance away. Okay, speed challenge is short distance away. 782. Let's see whether we can do better. Alright. Copy. 782. No, before that. This is a size. Alright, nicely done. Go to here. Paste. Okay. Size 782, is it? 782, yeah, 782, 714. That's like 68 steps or something, I think. Alright, so for this level, year 41 sorting floor, I was trying out solving this thing online, okay, and I couldn't make progress towards the speed challenge. So what I did was I just gave up, okay. It was just a short try, then I realized that what I currently have is not sufficient, okay. And something I mentioned in my channel is I'm quite perfectionist and I try to not be so, okay, train myself not to do that. So I thought it's okay to give up. Alright, but it's really quite wasted, okay. It's really close. And also I thought it's nice to show my viewers, okay, how to solve it. Alright, so actually all I need to do is admit that I gave up. Alright, and I thought that is okay, and it's okay to pick up from there. And what I did was the second thing is I seldom ask for help, and I thought, why don't I ask for some hints, alright, on how to solve this thing. Alright, so the hint I got was actually what I have is pretty close, okay. I'm using insertion sort, alright. So it is possible to hit the challenge if I use online insertion sort, okay. You can try to Google what that means, okay. Check out the Wikipedia entry for insertion sort. It's a very efficient O(n) square algorithm, okay. That's why we are using it for this program, okay, because the faster algorithm is crazily hard to implement in assembly, okay. There's not much point to do that. Also, we don't have the machinery to do so. Alright, but the very painful thing is this sets of functionality. This procedure takes at least 6 steps, correct, from 18 to 23. What it does is to perform swap, okay, swap the value between 2 cells. Alright, so something good about doing online, we try to reduce the need of swapping. So every time I see a new input, correct, instead of throwing it in, I should actually throw it to temp. Okay, so this is general strategy. Alright, throw it to temp. After that, I check where should I insert this thing in, correct. Should I insert in here? No. The next one, yes. Then I put it in and then move everything. Alright, move everything, insert. Let's see, one way is to do that. Oh, the other way is I could actually move everything first, okay. I could also move everything first. So let's say currently there's 3 value inside, correct. There's the 4th one I take. I want to figure out where it go in, okay. I can move the 3rd value up first, okay. See whether I should chop this one in. If not, move the 2nd value up. Should I chop this one in? Yes, chop it in. Alright, then everything will be aligned. That's good. Okay, that's good. So online insertion sort. Okay, let's give it a try. Okay, so let's see, we want to keep temp, we need length. Alright, so same thing, we have to copy from, okay, I'm just going to implement it from scratch, okay. I think the algorithm is going to be a bit different, okay. Online insertion sort, still insertion sort. I likely couldn't really use the previous structure. Might as well code from new. Alright, so but the start is the same. I think I copy from 0, I copy to length first thing, and then the next thing to do is I can actually check out, okay, this is meant to be an efficient code, right? Okay, so take from inbox, I can actually immediately copy to cell 0. Okay, just copy and leave it there. Alright, just copy and leave it there. After that, I want to bump up the length. Alright, bump up the length so that the next thing go to 1. Alright, then I'm going to take from the inbox and then copy to temp. Store it in temp first. Alright, I have one element here. I should copy it to here. Okay, so both of them are the same. Okay, the idea here is to reduce swap. So the way to reduce swap is to make use of the fact that moving is just 2 steps, swapping 6 steps, right? So we just pre-move. Okay, so there is a half chance that I need to move this one up, correct? Because half chance this new element is going to go inside here, so I shouldn't move up. Okay, the other half chance I move up and then new element go inside here. Alright, so I move up first. So copy from let's see, copy from, I want to copy from the end of the length. I want to copy from the end of the length, which is cell 0 to cell 1. Cell 0 to cell 1. Okay, cell 0 to cell 1. So I don't think I need a minimum anymore. Okay, instead I need the previous value, I minus 1 I. Okay, so length, let's see, before I bump the length, I actually need to copy to this. Before I bump it, I need it to be 0. Alright, before I bump it, I need it to be 0. Then after I bump, I need this to be 1. Okay, this is 0, this is 1. Alright, then I'm ready to do that. So copy from what's being pointed to here, cell 0, copy to cell 1. Okay, copy to cell 1. After that, I have this value. I should subtract it with temp. Correct? Subtract with temp. Subtraction with temp, I have only checked whether it's negative, right? Okay. What if it is not negative? Okay, we don't care about negative part first. What if it's not negative? That means this value is larger. So it is correct, we should have moved. That is correct. Correct, we should have moved. So after that, I should then subtract them. Okay, I should subtract them. So I should subtract this by 1 and subtract this by 1. Alright, so then in this case, the move is correct. I should bump down I should also bump down I minus 1. Okay, then I should repeatedly check. But then if I actually reach 0, then we are done. Temp should immediately swap inside. Temp should immediately be assigned inside. Okay, so if it is 0, then what I should do is I should amortize. I should amortize this part. I think I should amortize this part. Let's assume I don't amortize it first. Okay, then I should copy from temp, copy to what is pointed by let's see, I. Actually, both values are the same. It could be I, it could be I minus 1. Alright, so it depends on the other part of the algorithm. Alright, let's figure out for the other part of the algorithm what's the best way to do. Okay, so if it's 0, we are done here. If we copy from temp, we copy to I. We are ready to take the next value in the inbox. Okay, we are ready to take the next value in the inbox. So this one shouldn't copy to 0. It should probably copy to cell I minus 1. Actually, that doesn't matter. No, this doesn't matter. This one. Okay, this one. After that, you'll copy to temp. Alright, so when we copy to cell I, we are done with this round. We are ready to take a look at the next inbox value. Alright, so this is correct. We are ready to take a look at the next inbox value. Let's see. Then let's check to make sure that the loop is correct. So this is consistent before we touch the negative. Alright. So if we copy inbox to temp, alright, what should we do next? We should copy from let's see. This is the move up. This is the moving up. Alright, this is the moving up. But then my values are not good. Okay, it's actually here. After I finish slotting it in, so just now I only have one input, right? I read the second input, I managed to slot it in. Okay, so it's either the first second or the second first. So now my length is 2. I should bump it up. After I bump up, the length is 2. This is my new I. Alright, that makes sense. Alright, that makes sense. Then this one is a bit early. I most likely can only copy to here, then bump it down. Okay, this is I minus 1. I should create I first, then copy to it, then bump it down to form I minus 1. Okay, this looks good. I think this looks good. Sure, we'll optimize it again later. Okay, so this structure means that I could move these two things to the top and save a jump. Not sure whether it's a good idea. Let's just move first and figure out later. Alright, the last one, go to the top here. This one, go to the top here. The jump, don't need to go down then go top, just go top directly. Remove this. Whoa. Alright. So if it's 0, we have done that path. I shouldn't have done that path first. That is a case where it's actually not 0, right? It's not 0, then how? If it's not if I is not 0, so let's say we have 3 elements filled up in this round, right? This round, then we will touch it. Alright, this round, then we will touch it. So assuming that now length is 2. Length 2. 2 things being filled in, correct? These 2 things have been filled in, 23, 97. Okay, now I have 42. I want to figure out where it can go in. Okay, so my length is now 2, correct? And then I is also 2. I minus 1 is 1. I take the inbox value and the new temp is 42. Okay, the third element. Alright. Then I raise 97 up. Okay, I raise 97 up. Okay, cell 1 to cell 2. Then I subtract with 42 and realize that it is positive. If it's positive, then I should not insert 42 yet, correct? Not insert 42 inside here. I should check the previous round, correct? The previous round required me to bump I down from 2 to 1, I minus 1 from 1 to 0. Okay, that is correct. And I'm ready to check again. I am ready to copy cell 0 to cell 1. That's the next thing I should do. Copy from cell 0 to cell 1. Then 23, the value 23 is here, and I subtract with 42 and realize that it is negative. If it's negative, I will want to slot in to cell I. Correct? 23 is here, 23 is here, 42 should go into cell 1. This is 0, this is 1. So I should go into cell I. Okay, cell I. And that is okay. That is okay. It's exactly the same thing. It's exactly the same thing. Nice. So that saves some operations, I think. Correct? That is the same operation. If this works, I don't bump. Immediately I copy what is in temp to cell I and bump the length. Alright, so far so good. Let's check whether it follows what we compute mentally. Okay, what I meant is, okay, so 0 is copied to length. I take the inbox value, I copy to the first. What am I doing? Just now I changed this, change, and I forgot to correct it back. Okay, directly go into cell 0, that's all. Okay, 3 values, let's see how it behaves. Alright, take the first one, 0, put down. Alright, 88, just throw it there, doesn't matter. Okay, copy from temp. Oh, this is bad. I did amortization, I didn't follow through. There should be an amortization. Alright, this one. Okay, one more time. Take 0, copy to length, 80, cell value 80, put to cell 0. Okay, jump down, length is now 1. Okay, we have one element, we've seen one element. Okay, and that is the value of I, and then I minus 1 is 0. Take the next element, copy to temp. Alright, then I want to figure out where to slot this one in. How I'm going to do is to whatever is inside, right, I raise first. Correct, so there's 2 copies of it. Alright, it's currently in my hand due to this operation, which is good, so I take the subtraction and decide whether I should slot in the temp or not. Okay, if it's a positive value, I go on to the next one. I don't slot in. Okay, I still don't know whether it's time to slot in or not, so I should actually bump I down. Okay, and check before, but there's nothing before. Correct, there's nothing before. This is the first element already. Also, in that case, we know that 12 should go into cell 0. Alright, so if this is 0, then okay, temp value copy, throw to cell I, which is currently 0. Nice. Okay, length is now 2, that we have seen 2 elements. Correct, I is 2, I minus 1 is 1. Correct, take the next input, throw to temp. Then I copy from I minus 1, okay, which is 80, correct, cell I minus 1, 80, copy to the next cell. Okay, now it's in my hand, I subtract temp, realize it's positive, so I don't know whether I should slot 57 or not. Alright, so bump it down, this is 1, the other one is 0. Okay, we can do that because I is not 0 yet. Alright, and then rise and shine, copy 12, put up, subtract temp, realize negative. So if it's negative, 57 should go into cell 1. So you jump all the way up, copy from temp. Okay, copy to cell 1. Nice! I think this may work. So this is everything. How do I know that this is everything? Because the input value is 0. So the input itself is 0. Alright. What happened when, oh, by the way, this solution assumes that the string length is at least 1, excluding the terminating 0. Okay, and that's a good assumption. Alright, we are going to keep that unless we are told not to. Okay, inbox, if it's 0, it's time to end the whole thing. Ending the whole thing, we can amortize also. How? 0 copy to length, we need this, right? So it go all the way at the top, and then every code should go into the middle. There is a loop. At this point in time, we have no 0. Correct? Can we say so? I need to send from the first term all the way up to length. I need to send the first term all the way up to length. I and I minus 1, I cannot assume them to be 0. Correct, I cannot assume them to be 0. So I'm just going to make use of k. I actually don't need to, but since there's a k, why not? Okay. So copy from 0, copy to k. Alright, and then I am going to iterate. So check whether it is the subtract length. Okay, k subtract length, see whether it is time to stop the loop. Alright, so if it is negative, we should continue the loop, correct? If it's 0, that means k is the same as length, we should stop. If it's positive, k is larger than length, we should definitely have stopped already. Alright, so this is the place to stop and you'll naturally continue. That's nice, okay? So you'll naturally continue. So if this is negative, what should we do? If this is negative, sorry, this is wrong. It should be like this. Everything happened in between. Alright, copy from 0, copy to k, subtract length. If it's negative, it is time to do amortization again. Okay, this should happen all the way before that reaching code. What should we do here? We should outbox, copy from what k points to, and outbox that thing. But I don't want the reset. I actually don't want the reset. So I have no choice. This amortization need to be a little bit more friendly. Okay, this amortization need to be a little bit more friendly. It has to go after. Okay, outbox. Okay, seldom do we see this, but no choice. The thing no choice here is immediately when we jump up, we are going to jump down again. Not immediately. Okay, not immediately. No, not immediately. We are going to after we jump up, we are going to copy 0, copy to k, then jump down. And then we subtract the length, see how it looks like. Okay, copy from k, copy to outbox, and then we should bump it down. We should then bump k. Okay, we should bump k down to the previous value, to a smaller value. Then we subtract length and check. Looks good. Actually looks good. Let's see whether it works. Alright. The first 3 elements will be processed correctly. We'll let them process, and then it slots in correctly. Alright, so it slots in correctly. It's time to stop. I take the next input value. This is 0. Okay, so I currently hold 0, so I don't need to copy from 0 again. I just copy to k. Nice. I should do that later. Okay, remove that one step. Okay, copy to k. What happened? Subtract length. Alright, if it is negative, currently it is, okay, k is really small. Alright, if it's negative, then I take what's here, I outbox it. Bump it up, k is 0, bump up k, don't need 0, we want to remove that. Okay, try again. Alright, get the first 3 value in, reach reading of 0, come on, now. Alright, so we are holding on to 0, right? Immediately I can copy to k. Nice. Subtract the length. Yes, it's -3. Jump. Copy from what k points to, outbox it. Bump k up to 1. Subtract length again. Still negative. Takes the next thing. Throw. Bump k again. Subtract. Still negative. Take the next element. Go. Bump k again. subtract, no longer negative, time to continue, and rise and shine. And reset length. Looks good. I think it can go to completion, I think. But that depends on subtraction of characters. Subtraction of character is pretty stupid. I don't think I do any addition of characters. Sorry, I mean, in this game, you can subtract character but cannot add character with number to get another character. Sadly, there's a limitation over there. While I was talking about it, the character part is done. And that sounds like a good news. That sounds like good news. That means the algorithm is fast enough for short streaks. Okay. Let's hope it looks okay. Let's hope it looks okay. So far so good. Oh, nice. Okay, complete. Let's see about the speed challenge. Oh, it actually hit the size challenge. Interesting. Yes! Whoa! Yo! Oh, that feels good. That feels really good. Sorting floor. You can do that for sorting floor. Wow. Okay, I actually hit the size challenge and the speed challenge. Wow, so I actually don't need the previous size. Wow. Manners. Okay, sure. Alright, wow. Alright, so just this code is sufficient. I'm going to copy this code. Paste it here. Yes. I'm just going to store one. This one, the online version. Really impressive. Okay. Then that's it. Alright. We complete. And we have everything. Whoa! Okay, I actually successfully completed this game with everything. Wow. That feels good. I don't think I had the ability years ago when I was playing this. Yay, congratulations!
Instruction follower.
Invaluable instruction follower. Yes, I have. Yep.
We've replaced you with this electronic box.
Sure. It's safely in someone else's hand, right? Okay. The computer took over the job.
List of simple instructions.
Sadly.
Called a program.
Yep.
It has a small
Better
amount of
instruction
memory to
follower.
store data while processing.
Yep.
Like tiles on the
The
floor
tiles on the
It has
floor.
inputs.
and outputs.
Sure.
These simple instructions can be used together in infinite combinations.
Right.
To build just about anything you can
But
imagine.
frankly, to be really frank, they currently couldn't write program that well. Okay, observe that the human is still the one who writes the program. Okay, so it's not so easy to be taken over. But one day, programmers may be taken over by program the job, and then we'll all go out of business. All right. However that goes. Right, and that's the end. The elevator, I think, represent just now. Elevators coming down. Alright. Yeah. Very bleak stories of machine taking over things. Alright. Wow. Okay, and the unknowing me just come out of this whole thing. Yeah, damn lame. Sure. Alright, sure. Okay, yay, human resource machine. The creators, okay, kudos to them. This is a very interesting game, okay. Not really what I enjoy. Wow, Carol's still alive. Carol is just, in the wheelchair. Carol's still alive. Wow, from so tall building, Carol jumped down and is alive. Happy for you, Carol. Okay, but it is not really a kind of programming I enjoy, but good. It's a good experience. Okay, it's definitely a good puzzle game. I recommend people to try. Okay, important thing is to know yourself. You may end up liking it, even if it's not. You may know that you are capable of solving it. Okay, so it's a puzzle game is a powerful self-discovery for myself. Okay, that is done. Yay. Alright, there are two more. Okay, 42 years, very old. Two more achievements left, I think. One of the achievement is I try to finish with too slow, being too slow. I couldn't do it here, correct? There's only input and output. Okay, I need to find a way to finish really slow. Input, output, jump. Input, output, jump. Might be able to do that. Just with jump, I think is sufficient. Okay, just input, output is not sufficient because they all move the program ahead. If I take wrongly, the program will complain. If I give wrongly, the program will complain. Input, output, jump is possible. Okay, so the fastest, the fastest, correct. Now it's about speed, right? Okay, now it's about speed. Alright, I need to create a program that is take even longer than this one, which is take from inbox, throw the outbox, and jump, keep jumping. Alright, so by the way, this was the previous challenge for this is the previous speed challenge. Okay, this is fast. Alright, and this actually got me the inefficient achievement, having too long a size, because effectively size 3, 1, 2, 3 can solve this whole thing. So I have longer than 12, so I get an achievement, I think. Okay, don't really remember, I think it's 4 times. Alright, now I need to create a program that is slower than this. Okay, 25. I need to create one that takes 100 steps. Wow, 100 steps. 100 steps. Okay, but there's no iteration, and that will make this one a little bit hard to write. It can be done, alright. I just add in enough jumps. Okay, I just add in enough jumps. 100 of them, I'm done. I don't think you want to sit through watching me doing that. Alright, so I most likely need some more things on the floor to help me out. Right, some more things on the floor to help me out. Add them together, put the result in the outbox. 2 things, add them together, put the result in the outbox. Sure. Let's see whether there are things that can make it even more inefficient, but easier to write. Okay, send all things that are not 0 to the outbox. All things that are not 0 to the outbox. Okay, so the program has to be really slow, right? The program has to be really slow. So I take the inbox value. Correct. I copy to the first cell. Okay. Then I copy to the second cell. Oh, I cannot bump. I cannot bump. No, don't want. No. Oh yeah, I can bump. It will be really useful. So somewhere around here, I guess. Storage floor. Okay, so let's see. Inbox is an address. Each address refer to a tile. Okay. Let's see how we can make it really inefficient. How can we make it really inefficient? Okay, bump is out already. Trying to choose one that's easier to implement. Yeah, doesn't take me too long. Countdown. Okay, send to the outbox, followed by all the number down to 0 is a countdown. Sure. Copy. Yes. Put it to here. This is a size function. I should take the size function. That is already slower pace. Okay. Take the inbox, copy to 0. Alright. I should outbox this thing. But before I outbox this thing, I should count down. So yeah, doing all the lame stuff. Alright, so before I outbox this thing, I should just count it down. So copy to 1, start bumping it up or down. I shouldn't do it here. I can do it here, right? Okay. Here's the place where we bump. Okay. So if it's negative, we go down there. If it's 0, we just return. Okay. So if it's positive, we'll bump the value down. We'll bump 0 down. But we are going to copy the current value to 1. Okay. Copy the current value to 1. And we are going to bump 1. We are going to bump 1. And only when it's 0, then we are going to let it go. Okay. Same thing here. We are going to copy our value to 1. Okay. Then we are going to add 1. And then we are only going to let it go if it is 0. We are only going to let it go if it's 0. Otherwise, we are going to continue. Okay, this is deliberately inefficient. Yeah. Okay, we are only going to let it go if it's 0. Yeah, deliberately inefficient. Let's try what will happen. I take 8. Correct. Go to our box. Yay. Okay, and then if it's negative, I copy to here. Then bump this one down. Continue. Okay, bump it down all the way until it's 0 first. Then I continue. This is a really time waster. Alright, you're going to see through this with me for a while. This is for sure more than 4 times slower than a good piece of code. It's really inefficient. Okay, so meanwhile, I will hasten it out in the actual video I process. No worry, I'm not going to look through the whole thing. Okay, but let me take the opportunity to say that it's possible to write really inefficient code in real life. As you can see, it solves the same problem. It's the exact same problem solved, but it is so much inefficient. Alright. Okay, so we need to be really careful about that as programmer, okay, to avoid this kind of code. It's responsibility. Alright. Wow, nice. This is more than 4 times. I hope. It's really close fight. 32, 3 to 8 is 4 times. I'm only slightly above 4 times. Wow. Okay, that should get me the achievement. I'm surprised why they are not showing up. Alright, but they should anyway. I guess overlay is currently not enabled or was not sure. Okay, this is done. So that is all for this game for now. Going ahead, I may move to its sequel, the 7 Billion Humans. I may try other game. Okay, I bought some game on my birthday, yay, and some puzzle game, and I'm interested to try them out. Alright, so you'll start seeing them showing up, I guess. Alright, if you enjoyed the video, do like and share. Also, click on the subscribe button, join me on more gaming fun on other puzzle games or what's not. Alright, so Papa is done. Enjoy.